Good morning, good afternoon, good evening, everyone. Thank you for registering for our webinar hosted by the Institute for the Study of Complex Mineral Development, or IPCON. I am Dominique Pion. I am the Director in charge of Strategic Alliances at IPCON. So we've identified 5 leading trends and innovations in the underground mining industry. Our webinar will be divided in 2 parts. First of all, we speak about 4 leading trends in the underground mining industry, and then we'll speak about 1 leading innovation in that industry, that is IPCON's silicate capsules. So we've identified top 4 leading trends in the underground mining industry. The first trend we've identified is that mining productivity hit new lows. The second trend, in these difficult economic times for the mining industry, there is a greater need to increase the efficiency of mining operations and to cut costs. The third trend is that mines are getting deeper. We'll briefly discuss the implications of that fact. And then we'll discuss the trend toward increased automation of drilling and installation of rock bolts and capsules. So the first trend, mining productivity has hit new lows. According to a recent report by Deloitte, in 2013 we hit new lows in terms of mines productivity. Here you can see 2 figures. On the left, you have a graphic that shows the cost to build 1 ton of iron ore in US dollars. In green, you have the cost in Australia, which went from $100 US in 2007 to $195 US in 2012. In blue, you have the same cost for the rest of the world, which went from $96 in 2007 to $150 in 2012. On the right hand side of the slide, you have a graphic that shows the cost to build 1 ton of thermal coal. In green, you have the cost in Australia, which went from 61 US dollars in 2007 to $176 US in 2012. It nearly tripled. In blue, you have the cost in the rest of the world, which went from $73 in 2007 to $106 in 2012. Despite commodity price weakness, input and production costs, everything from labor and energy to equipment and supplies, remain stubbornly high. Despite the fact that metallurgical coal prices dropped from $330 per ton in 2011 to $150 per ton in September 2013, while thermal coal commodity prices fell to under $80 per ton for the first time since October 2009. So we must uncover hidden costs. Mining lower grade deposits also gives rise to a host of hidden costs. Between 2001 and 2012, the weighted average head grade for copper fell by almost 30%. Nickel, zinc, and gold grades also plummeted. Some gold projects yield less than 1 gram per ton. With 75% of new base metal discoveries hidden at depths in excess of 300 meters, this practice is pushing up strip ratios, reducing the economic sustainability of mining lower grades. As mining companies work to rectify their cost imbalances, many will need to refocus on return on capital employed by making a business case for producing fewer ounces or tons at higher grades. In these circumstances, even a small change that can increase productivity incrementally can make a positive difference and should be adopted. IPCON silicate capsules can constitute such a change. The second trend that we've identified is the need for greater efficiency. In an increasingly volatile global market, what can mining companies do to improve operations, become cost efficient and agile, and maximize value across their business. As the uncertainty in the global economy continues to impact the demand for metals and mining products and their prices, mining companies are under pressure to achieve speed to market and get things right the first time. For companies trying to improve business performance in an ever volatile environment, the challenge lies in rethinking and addressing a range of issues across the business with an eye toward maximizing value. For mining companies, waiting and watching while markets become less volatile is no longer an option. Instead, mining companies can improve their ability to respond to market conditions and increase value in an ever volatile environment by considering two actions to take. First of all, to focus on core operations, and second, to optimize core operations. Those that take positive steps now to be cost efficient and agile stand to create a foundation for sustained high performance. To maximize value in a volatile environment, mining companies must, first of all, focus on core operations. That means to realize value in weak markets, companies need to evaluate and determine core activities and functions and outsource non-core ones to a business partner, increasing its ability to focus on core competencies, speed up time to market, and reduce costs. And the second thing that they must do is optimize core operations. Miners can pull various levers, such as mature analytical planning and management technology solutions, centralizing data primary activities through the control room, using fly-in, fly-out options to maximize labor efficiencies, and so on, to optimize core operations and create greater value. IPCON silicate capsules can help in this regard by increasing the productivity of a mine and allowing to cut costs. The The third trend that we've identified is the fact that mines are getting deeper. We'll briefly discuss the implications of that fact. The deeper the mine, the higher the stress level exerted on the surrounding rock, and the need for reinforcement increases significantly. As mines get deeper, there are challenges associated with providing sufficient load transfer capability in primary and secondary roof support systems. Having bolting products that can cope with increased stress loading, squeezing, and dynamic loading capability is becoming increasingly important. The geothermal gradient is the rate of increasing temperature with respect to increasing depth in the Earth's interior. Away from tectonic plate boundaries, on average it is about 25 degrees Celsius per kilometer of depth. In some places in South Africa it is as low as 9 degrees per kilometer of depth. That may partly explain why South Africa has the deepest mines in the world. As mines get deeper, the temperature of the face rises a great deal. IPCON silicate capsules have a great advantage over resin capsules in this regard. They can be used at temperatures of up to 50 degrees Celsius. Resin capsules auto-ignite at 31 degrees Celsius. For example, the Totona mine, or also called the Western Deep Number 3 Shaft, is a gold mine in South Africa. At 3.9 kilometers deep, it is currently home to the world's deepest mining operations. The mine today has some 800 kilometers of tunnels and employs some 5,600 miners. The mine is so deep that temperatures in the mine can rise to life-threatening levels. Air conditioning equipment is used to cool the mine from 55 degrees Celsius down to a more tolerable 28 degrees Celsius. South Africa is at the forefront of deep mining. Agnico Eagle Mines, La Ronde Mine in northwestern Quebec, is one of the deepest mines outside South Africa. It operates at about 2.2 kilometers below the surface. Before closing in 2002, the Olmsted Gold Mine in South Dakota was considered the deepest mine in the Western Hemisphere at about 2.45 kilometers. Nowhere else do mines go so deep as in South Africa, and lessons learned there from attempts to extend the lifespans of mines will be applicable globally, not just for gold, but for extracting other minerals underground. The Mponeng mine in South Africa, owned by Anglo Gold, has plans to dig to 5 kilometers. The trend toward deeper mines increases the trend toward automation and mechanization. For example, Anglo Gold has given assurances that all mining below 4 kilometers will be fully mechanized, with few mine workers involved, in order to minimize the danger. So, the fourth trend that we've identified is increased automation. Artificial ground support has developed into a refined science over the past 20 years. From reactive support systems such as timber props and steel supports to active systems such as roof bolts and cable anchors, ground support technology has now developed efficient systems that work very well in almost all instances. Steve McAway, marketing manager for DWDAG Systems International's Asia Pacific division, explains. This is a quote: Australian mining in particular is such a safety conscious industry. Change only takes place in incremental steps. We are seeing a move to more remote operated mining equipment with fewer people present at the face. This means that manual handling, respiratory hazards, crush hazards, eye and hearing protection remain key priorities in new product development. End of quotation. Meanwhile, the high cost of labor in some markets and the drive to improve safety by reducing the number of personnel exposed to risk is fueling innovations in bolting automation. Ground support systems can be installed mechanically or manually, and varying degrees of automation are available with certain machines. Mechanized bolting involves operator supervision at every stage. The operator performs the bolt installation using mechanic or hydraulic means controlled with levers and joysticks. Bolting rigs can be fully or semi-mechanized, where part of the bolting sequence or the full sequence is performed using the rig. Automated bolting is fully mechanized and does not require operator supervision. Many manufacturers offer rigs that can be partially or fully automated. Fully automated rigs would be pre-programmed to drill holes and install bolts in accordance with a digital mine plan. Manual installation, where the operator uses a handheld drill and installs the bolts with a wrench or a dolly, is still the most common technique in underground hard rock mines, mainly because it is more productive than using mechanized rock bolters. However, the use of semi and full mechanization for bolting is increasing rapidly as mines strive to improve safety records. Manual bolting is both labor intensive and hazardous due to the risk of falling objects, and the benefits of enclosing the operator in a cabin or enabling bolting from a remote location are significant. Rock bolting attachments, special bolting rigs, and semi-automated units for the installation of conventional rock reinforcement systems, such as friction stabilizers or cable bolts, have been successfully introduced to the market in the past decades. However, the increasing demand for fast and safe one-step rock bolting procedures resulted in significant changes in the design of bolting automation units. The main issues are the integrated view on the rock bolt itself, the installation mode, and the required machinery. A rock bolt automation unit for self-drilling rock reinforcement systems must feature a reliable and easy-to-handle interconnection with the associated supporting machinery, as well as a tough and lightweight design. In addition, The integration of the automated handling into the drilling procedure requires measures of synchronization and optimization of corresponding working procedures. IPCON silicate capsules can be mechanically and automatically installed using any hydraulic device. So now I will introduce my main topic, which is what we've identified as the top innovation, that is IPCON's silicate capsules. So I will speak briefly about cement capsules and resin capsules because IPCON silicate capsules advantages are best shown in comparison to these competing products. So as you probably know, capsules are installed at the bottom of a borehole and allowed to permanently fix a rock bolt in a borehole. Three types of capsules are currently available depending on their content. The first type is cement capsules, second type resin capsules, and the third type silicate capsules. IPCON perceived the following limitations in the existing capsules. For cement capsules have a short shelf life of 6 months because the shell of the capsules is made with a water permeable material. During their storage, the capsule is affected by any humidity in the ambient air. They need to be soaked in water before being installed. Once installed in the borehole, they take 3 to 5 minutes to stiffen. They allow for a difference in diameter between the rock bolt and the borehole of about 4 to 8 millimeters. Resin capsules. Resin capsules are notably composed of styrene, a highly toxic material. According to the U.S. Environmental Protection Agency, if inhaled, styrene vapors can cause damage to the gastrointestinal tract, to the kidneys, and to the respiratory system. I have another quote from the U.S. National Toxicology Program. So the U.S. National Toxicology Program has described styrene as reasonably anticipated to be a human carcinogen. Unless a mine has a very good ventilation system, after installation of resin capsules, a mine usually has to be evacuated of all its workers for 2 to 3 hours to allow for a proper ventilation and an evacuation of the toxic vapors emanating from the resin capsules. This can have a significant impact on the productivity of a mine. Resin capsules have a short shelf life of only 6 months, because after this period of storage, the resin contained in the capsules hardens. They should be stored at temperatures below 20 degrees Celsius and can only be used at temperatures between plus 10 and plus 25 degrees Celsius. At temperatures lower than 10 degrees Celsius, the resin gets hard and does not react properly with the fixing agent. At temperatures above 25 degrees Celsius, it loses its chemical characteristics and its bearing capacity. These are not re-established even if they are stored at lower temperatures later. They constitute a fire hazard and can auto-ignite at temperatures above 31 degrees Celsius. Resin capsules allow for a difference in diameter between the rock bolt and the borehole of 4 to 6 millimeters. Each resin capsule is in fact composed of 2 capsules, one inside the other. The inside capsule contains the fixing agent. The diameter of this inside capsule is 4 to 5 millimeters. With resin capsules, there is a higher risk that the inside capsule will not break when the rock bolt is installed in the borehole. So, my main topic is now IPCON's silicate capsules. IPCON invented a new fixing agent for silicate capsules in order to create a product that presented the advantages of cement capsules and resin capsules without their drawbacks. IPCON holds a patent for its new fixing agent and silicate capsules in Kazakhstan and Russia. A patent is pending in virtue of the Patent Cooperation Treaty. Its silicate capsules are entirely composed of inorganic, non-toxic, non-flammable materials. Being non-toxic, the installation of silicate capsules does not require the evacuation of a mine to avoid intoxication by styrene vapors. The stiffening time of the mixture of the silicate capsules is only 1 minute. The shelf life of the capsules is 3 years. They can be stored at any temperature below 50 degrees Celsius. They allow for a difference in diameter between the rock and the rock bolt of up to 12 millimeters, permitting savings on the rock bolts of up to 30%. With IPCON silicate capsules, the fixing agent is inside another capsule of a diameter of 17 millimeters. So here you have two drawings. On the left hand side you have IPCON silicate capsules, and on the right hand side you have a regular resin capsule. You can see the diameter of the inside capsule. For IPCON silicate capsules it's 17 millimeters. For resin capsules it's only 4 to 6 millimeters. In silicate capsules, the diameter of 17 millimeters of the inside capsule ensures that this inside capsules will be broken and that the fixing agent will be released and will mix with the hardener. The savings estimate of 30% on the cost of rock bolts is based on a comparison of IPCON silicate capsules with resin capsules. This is because in IPCON silicate capsules, the diameter of the inside capsule of 17 millimeters allows for a greater difference between the diameter of the rock bolt and the diameter of the borehole. With IPCON silicate capsules for a given borehole diameter, you can use rock bolts of a smaller diameter compared to cement capsules or resin capsules, allowing you to save up to 30% on the cost of rock bolts. Furthermore, on average, the volume of the contents of silicate capsules grows by 2 to 3% after its installation, allowing for a tighter installation of the rock bolt. On average, the volume of the content of a resin capsule shrinks after installation. IPCON silicate capsules offer permanent roof support, usually for the whole life of an operating mine. They are easy to install and provide an effective protection against corrosion. They can be installed even in a very humid environment. To conclude, IPCON has been selling its silicate capsules with a lot of success in Kazakhstan underground mines since 2009. IPCON is looking for opportunities for its silicate capsules in the civil engineering and construction markets. IPCON wants to find partners worldwide who would be willing to act as its licensees to produce and to sell its silicate capsules abroad, both to the mining industry and to the construction industry. Dr. Balat Kassian, the director of IPCON, will travel to Canada in February and March 2014 and to Australia in April 2014. He will be looking for collaborators and local places to test our silicate capsules, such as laboratories, research centers, rock bolt producers, and underground mines. Anyone who could be interested in acting as a licensee for silicate capsules, for IPCON's silicate capsules, of course, should contact us at dpion@ipkon.kz or on the phone in Canada at 1-514-516-1178. You can also fill a registration form by clicking on the following address: www.ipcon.org/press-releases. Thank you for your attention, and for any additional information, please visit our website at www.ipkon.org. Thank you.